All right, so today's class we are looking at solving a system of linear equations by algebra. There's two methods we're going to look at today, and the first method is called substitution. So again, you do have this under modules. So these are the steps for substitution. So the first thing is you're going to choose the simpler equation and you're going to express it as one variable. So basically, if for example here we have x and y, you're going to express it as x equals or y equals. Next, you're going to take the expression from step 1 and you're going to substitute it into your second equation. Once you've done that, you can solve for that variable that's left in that equation. After that, you're going to take that value that you just figured out and you're going to substitute it from step 3 into the equation that you used in step 1. And then you can find the value of the second variable. And then you'll have solved for both x and y, or both the variables, and that will be the solution to that system of equations. So let's take a look at our first example. All right, so here we have our two equations, x plus 4y equals 17 and 2x minus y equals 7. So the first thing we have to do is choose the simpler equation and express it as one variable. So let's do the first equation. If I move the 4y over to the right-hand side, I will express my first equation as x equals. So I'm just going to show that right here. So all I've done here is I'm going to subtract 4y to the right-hand side. So it's going to become x equals negative 4y plus 17. All right, now that we have our first equation expressed as x equals to, I can now substitute this into my second equation. So into my second equation, which is 2x minus y equals 7. All right, so 2x minus y equals 7 becomes 2. Wherever I see x, I'm going to substitute this here, negative 4y plus 17. And then minus y, and it equals to 7. All right, so now that I have substituted, you'll notice in the equation, I don't have an x in the equation anymore. I have a y and a y, so therefore now I can continue and solve for y. All right, so first thing I'll do is multiply this out. So 2 times negative 4y, that gives me negative 8y. 2 times 17 is plus 34. Then I have the minus y, and then it's equal to 7. Okay, so next I'm going to collect like terms. I have negative 8y and negative y, so collect those together. That gives me negative 9y plus 34 equals 7. Subtract your 34, so I'm going to subtract 34 on both sides. That gives me negative 9y is equal to 7 minus 34, which is negative 27. And then lastly, I just have to divide by negative 9 on both sides. That gives me y is equal to 3. All right, so we have now solved for y. So we still have to solve for x though. So what you're going to do with this, y equals to 3, is you're going to substitute it into the first equation. You're not going to substitute it back into the equation we just used. You have to use the first equation, which is x plus 4y equals 17, which is what I will do next. So x plus 4y is equal to 17. I know that y is equal to 3, so I'm going to substitute it right into my y here. So x plus 4 times 3 is equal to 17. And notice I did use brackets, always use brackets when substituting. So we get here x plus 12 equals 17. Subtract the 12 on both sides. X will equal to 17 minus 12. So x is equal to 5. So we solved for our y value and we've solved for our x value. All right, so x is equal to 5 and y is equal to 3. And if we were putting that as a point on the graph, it would be 5, 3. That's the point on the graph. All right, so the last thing we're doing here with that same example is that we have to verify that the solution satisfies both equations. So our solution was 5, 3. We just have to substitute it into both equations, make sure the left side equals the right side, and that way it is verified. All right, so x plus 4y equals 17. That will become 5 plus 4 times 3 has to equal to 17. So our left side has to equal to the right side. So here we get 5 plus 12 has to equal 17. 17 equals 17. So left side equals right side, and that is verified. 2x minus y equals 7. That's our second equation. So let's verify this as well. 2 times 5 minus 3 has to equal to 7. We get 10 minus 3 equals 7. And it is verified. 7 equals 7. So left side equals right side. So this solution, 5, 3, is verified for both lines. All right, so our next example, we have our two equations. So we have a 4x plus 3y equals 0, and we have an 8x minus 9y equals 5. So again, you want to choose the simpler equation and express one variable in terms of the other. So this one looks simpler. There's a 0 here. It'll be simpler to rearrange. So again, let's rearrange this equation in terms of one variable. So let's put this one into y equals. So we have 3y equals to 0. I'll subtract the 4x. So 3y equals negative 4x. All I've done is subtract the 4x over to the right side. And then I'll have to divide by 3. So we end up with y equals negative 4 over 3x. All right, so we have now solved for y. We're going to take this equation now and we'll substitute it into the second equation wherever we see y. So here we will end up with 8x minus 9. Here we have our y, so we're going to have to substitute the negative 4 over 3x. And it's equal to 5. Okay, and let's multiply this out. So 8x and negative 9 times negative 4 over 3 gives me 12. And that is equal to 5. All right, so this part, negative 9 times negative 4 over 3, make sure you just put that into your calculator and you'll get 12x. All right, so now we're left with 8x plus 12x equals 5. We can combine these like terms. 8x plus 12x gives me 20x. So 20x is equal to 5. Then I'm just going to have to divide by 20 on both sides. And x will be equal to 5 over 20. I'm going to reduce that to 1 over 4. All right, so we now have solved for x. For x is equal to 1 over 4. All right, so our last step is we have to put x equals to 1 over 4 back into our first equation here and solve for y. Okay, that is what I'll do next. So we've already put our equation into y equals form. So y equals negative 4 over 3 times x, our x is 1 over 4, so just multiply by 1 over 4, and that will give me a negative 4 over 12, and I'm just going to reduce that right away here to negative 1 over 3. All right, so our x is 1 over 4, and our y is equal to negative 1 over 3. And the last step we have to do is just verify that for both equations. All right, so we're just going to show the verification for both equations here. So for x, so 4 times 1 over 4 plus 3 times negative 1 over 3 has to equal to 0. And when you put this into your calculator, we do get 0 equals to 0. So that is verified. And on this side, we would put in 8 times 1 over 4 minus 9 times negative 1 over 3, and that has to equal to 5. So again, just put that into your calculator, and we get 2. And we get plus 3 has to equal to 5, and both sides equal to 5. So that is verified as well. Okay, so our second method of solving algebraically is the method of elimination. And this method also has 4 steps. So first step is, if necessary, you're going to multiply each equation by a constant to obtain coefficients for x or y that are identical, except for the sign. And this will make more sense when we do the examples. Next, you're going to add or subtract the 2 equations to eliminate one of the variables. So we want to eliminate either x or y. Once you've eliminated a variable, you can solve for the variable that's left in the equation. Solve for that variable, and then lastly, you can substitute it into either of the original equations to determine the other variable. So let's take a look at our first example. All right, so here are our 2 equations. We have 2x plus 7y equals 13. And then we have 3x minus 7y equals 2. So the thing to notice in this system is you have a 7y and you have a negative 7y. So we can eliminate our y's by adding the 2 equations together, because 7y plus 7y added to the negative 7y will bring this to a 0. So our variable y will be eliminated. So what I will show here is that I'm adding the 2 equations. All right, so adding the equations, 2x plus 3x gives me 5x. 7 plus negative 7 is 0, so that gets canceled out. And we're left with 13 plus 2, which is 15. All right, now we can just solve for x. It's 5x here, so divide 5, divide by 5, and we're left with x is equal to 3. All right, once we have x equals to 3, you can now substitute that into either of the original equations to get the value for y. So I'll just use the first equation. So we'll just do that here. So 2x plus 7y equals 13. That was the first equation that was given. I know my value for x. I'm going to substitute it in here. All right, just like that, 2 times 3 is 6. So 6 plus 7y equals 13. Subtract 6 from both sides. That will leave me with 7y equals 13 minus 6, which is 7. Divide by 7 on both sides, and that gives me y is equal to 1. All right, so x is equal to 3, and y is equal to 1. So the last thing you would do here is verify verify the solution for both equations just by substituting them into both equations. All right, so our next example, we have 2x plus 6y equals 6, and we have 2x plus 3y equals to 4.5. So in this case, again, notice we have a 2x and a 2x in this equation. So to eliminate x this time, we have to subtract the two equations because it's positive 2 and positive 2. So 2x minus 2x will give me 0x. We'll eliminate that variable. So again, I'm showing my subtraction right here, and I'm just going to do this like a subtraction question. So we'll start here, 2x minus 2x, that's 0. 6y minus 3y is 3y. And then 6 minus 4.5 is 1.5. And then we'll just divide by 3 on both sides, and we get that y is equal to 0.5. All right, and all we have to do next is substitute this 0.5 into either of the equations. And I'll just use the first one. I'll show here, this is our value for y. So we're trying to solve for x now. So I'll use the 2x plus 6y equals 6. And I'm going to substitute this value 0.5 into the y here. So 2x plus 6 times 0.5 is equal to 6. And we get 2x plus 3 is equal to 6. And subtract the 3 over to that side. 2x is equal to 6 minus 3, which is 3. And then we'll divide by 2 on both sides. And since we have a decimal here, I'm just going to put this as decimal as well. 3 divided by 2 is 1.5. So there we have it. We have solved for our y, and we have solved for our x. And the last step you would do here is just verify that these solutions work for both of the original equations. So our two original equations at the top there. All right, so our next example, we have 2x plus 3y equals 4 and 4x minus y equals 22. So looking at our variables, if we added or subtracted our equations, it's not going to eliminate either of the variable. So in this case, what you have to do is multiply one of the equations so that you can make it equal to the coefficients that we see here. So we can multiply the top equation, you can multiply it by 2. That'll give us a 4x if we multiplied the top equation by 2. We can also multiply our second equation by 3 to get 3y, just like our first equation. So let's do that. Let's multiply our second equation, multiply it by 3. So this is how I show that I'm multiplying it by 3. All right, so once we multiply this, we have to multiply the whole equation by 3. I'm just going to show that over here. 3 times 4x is 12x. 3 times negative y is negative 3y. And then 3 times 22 is 66. So equals 66. So now we have our two equations. Now we have 3y plus 3y and a negative 3y. So I'm just going to rewrite both equations. So 2x plus 3y equals 4. And we have 12x minus 3y equals 66. So there's our two equations now. We have 3y and negative 3y. All right, so now we can add the two equations. So I'm just showing it that we're adding. All right, so it's important here that you show which operation you're going to use because you're trying to eliminate the y's. If you had subtracted, 3 minus negative 3 is is going to give you 3 minus -3 is +6. It's not going to eliminate. You have to add because 3 plus -3 will eliminate the y. All right, so here then 2x plus 12x gives me 14x. 3y plus -3y, that's canceled to 0. And then 4 plus 66 is 70. And then we'll divide by 14 on both sides. And x is equal to, I'm just going to grab my calculator, 70 divided by 14 is equal to 5. So there we go, x is equal to 5. So now all we have to do is substitute x equal to 5 into one of our original equations to solve for y. The original equation, I'm just going to use the first one. The first equation, which was 2x plus 3y equals to 4. I'm going to substitute in the 5. So 10 plus 3y equals 4. And subtract the 10. Leaves me with 4 minus 10, which is -6. And then divide by 3. And divide by 3. That leaves me with y is equal to -2. All right, so again, we have solved the equations. So the answer is 5 and -2. So the last step you would do is verify that that solution works for both of those original equations. Okay, so our next set of equations, we have 5a plus 3b equals 3, and we have 3a minus 7b equals 81. All right, so we can't eliminate either variable. So in this type of question, we have to multiply both equations. So let's say if we multiply our top equation by 7 and we multiply our bottom equation by 3, then we can eliminate our b's because we'll make both of them equal to 21. The other method you could use is make 5 and 3 equal to 15 by multiplying the top equation by 3 and the bottom equation by 5. All right, either way, we have to eliminate one of the variables in elimination. All right, so let's multiply the top equation by 7. I'm going to eliminate the b's. And so I'm going to multiply the bottom equation. I'm going to multiply by 3. Okay, so I'm just going to rewrite that out down here. So I'll do the first equation first. So that's going to give me 35a. And then 7 times 3b, that's plus 21b. And it's equal to 21. Next, the bottom equation, 3 times 3a, that's 9a. 3 times -7b, that's -21b. And then 81 times 3, I just have to check what that is. It is 243. All right, so now we have 21b and -21b. So we would add the two equations to eliminate the variable b. Okay, so 35 plus 9 is 44. B becomes 0. And then 21 plus 243 is 264. All right, and then we would just divide both sides by 44. And that gives me 6. All right, so we've solved for A is equal to 6, and we just have to solve for B. So you can put a into either of the original equations. I'm just going to go ahead and use the first equation. 5a plus 3b equals 3. And we know our value of a is equal to 6. So 5 times 6 plus 3b equals 3. 30 plus 3b is equal to 3. Subtract 30 on both sides. 3 minus 30, that's negative 27. And divide by 3 on both sides. Leaves me with negative 27 divided by 3, which is equal to negative 9. And that's it. So we have solved for A and B. The last step that you would do at the very end is verify that A equals 6, B equals negative 9 works for both of the original equations. All right, so we're looking at the same two equations as before, but this time I'm going to eliminate A. So to eliminate A, I'm going to make both of them equal to 15. So I will multiply the top equation by 3, and I'll multiply the second equation by 5. All right, so that gives me top equation 15a plus 9b is equal to 9. And our second equation, 5 times 3a, that's 15a. 5 times negative 7, it's negative 35b. And it's equal to 81 times 5. 81 times 5 is 405. Okay, and now we can see that we can eliminate the a's. But it's 15 and 15, so we have to subtract to get 15 minus 15, which will eliminate a. So 15a minus 15a, that is eliminated. Then we have 9 minus negative 35. Make sure you're doing that correctly. Put it in your calculator. So 9 minus negative 35 is 44. And then 9 minus 405 is negative 396. And then we'll divide by 44. And we get b is equal to negative 9. Just like previously, we had gotten b is equal to negative 9. So just want to prove that here, where we were doing it before, b was equal to negative 9. Okay, and now we just have to substitute negative 9 into any of the original equations. I'm just going to use the first one. All right, so b is equal to negative 9. I will substitute it right here. So we get 5a minus 27 is equal to 3. Add 27 to both sides. 3 plus 27 is 30. And then divide by 5 on both sides. And a is equal to 6. All right, and I just wanted to show that again. When we had done the equations previously, we had also gotten that a was equal to 6 and b was equal to negative 9. And we still get the same answers. A is equal to 6 and b is equal to negative 9.